Greetings, everybody. My name is Mr. Dominic. Yesterday we discussed about electrolysis. We talked about electrolysis. Well, we defined electrolysis. We defined different terms used in electrolysis, talking about electrolysis itself, electrolytes, and the electrodes, the cations, the anions, the ions. We also stated Faraday's first law, second law, driving the formulas, and also stating the various SI units. Today we're going to solve some questions under electrolysis. We're going to solve some questions under electrolysis. The assignment I gave you last night, I told you to find the mass of copper deposited. I already given you the assignment, so I won't write it again. I'll just collect the data. Find the mass of copper deposited on the cathode of a copper voltmeter if a current of 0.5 ampere, so I now, which is the current, is 0.53 ampere, is passed through it for 30 minutes. So your time is equal to 30. And I told you that you have to convert this time from minutes to what? To seconds. How do you do that? You multiply by what? By 60. So this should give us 1800 seconds. And our ECE, which is our electrochemical equivalent, was given to us as 3.3 times 10 to the power of minus 4 grams per coulomb. Yes, 3.3 times 10 to the power of minus 4 grams per coulomb. And by formula, we know that M is equal to ZIT. So what did I say we should calculate for? They say we should calculate for the mass. M is unknown. So substituting this directly, because we don't need to find any subject or formula, it's very clear and straightforward. What is our Z? Our Z is 3.3 times 10 to the power of minus 4 multiplied by what is our I? Our I is 0.53 and we multiply by what? A 1800. So if we should do this, if I write this, I'm going to have, if I write this, I'm going to have 1, 2, 3, 4, 0.33 multiplied by 0.53 multiplied by 1800. So if I multiply this very well, I'll have something like 0.00033 multiplied by 53 times 18. And what is 53 times 18? 53 multiplied by 18. This should give me, this time this will give me 4 carry 2. This time this should give me 40. 40 plus 2 is 42. This time this will give me 3. And this time this should give me 5. So this should give me 4, 5, 9. This multiplied by this, 0.00033 multiplied by 954, I should be able to have something like 0.315 gram. That's my answer. So if you have this, know that your answer is correct. But today we're going to solve more exercise. We're going to solve more exercise. We're going to look at more examples so that we can have better understanding of what electrolysis is. So the next example we're going to look at is this. Calculate the electrochemical equivalence, that's the ECE, if 158.4 gram of copper is deposited when a current of 2 ampere flows for 60 hours. Now we'll collect our data. If we collect our data, what are we going to have? We're going to have our ECE as unknown. What else again? We're going to have our mass as 158.4 gram. No need to change. We're going to have our current, which is I, as 2 ampere, and then we're going to have our second, which is, we're given 60 hours, so we have to convert it to what? To minutes, to seconds, by multiplying it by 60 times what? 60. So what is going to give us? 6 times 6 should give us 36. 36 times 6 should give us 360 plus 36. 360, that is 396,000 seconds. 396,000 seconds. Yeah, so 60 times 60 times 60 should give us 216,000. 216,000. Now, what are we looking for? From our formula, we have M is equal to ZIT. What are we looking for? We're looking for Z. So making Z the formula, we have to divide it by what? IT. This cancels this. Z is equal to what? M over what? IT. Now, substituting the values and solving for our Z. So Z is equal to, what is our M? Our M was given to us as what? 1 158.4 gram all over, what is our I? Our I was given to us as 2 multiplied by what? 216,000. Yes, 216,000. So if you calculate this, you should have something like this. When this comes up, it becomes this should give us 158.4 multiplied by 10 to the power of minus 3 over 2 times 216. Forget about it, I'm just trying to do my calculations. So from here, I should have 158.4 over this multiplied by this should give me 2, carry 1. This time is this 2, 2 plus 1 is 3. This time is this should give me 4, multiplied by 10 to the power of minus 3. So if you divide this, you should have something like 0.3666 times 10 to the power of minus 3 grams per coulombs. So this is your Z. So this is another example on how to calculate for our electrochemical equivalent. So this is the second example that we're going to look at. In the electrolysis of dilute H2SO4, using platinum electrodes, 10 grams of copper was deposited at the cathode. 10 grams of copper was deposited at the cathode. Calculate the amount of oxygen liberated at the anode. Chemical equivalent of oxygen is 31.5 grams, while chemical equivalent of copper is 63.5 grams. Please take note, there's a difference between chemical equivalent and electrochemical equivalent. Electrochemical equivalent and chemical equivalent are not the same. Electrochemical equivalent, which is your Z, and chemical equivalent are not the same. So please don't go and make that mistake trying to interchange them. It doesn't work like that. So please, I believe you have gotten down the question because I have to rub it up to be able to solve. I'll give you some time to finish up the question, or you can just pause the video, copy the question, then we can continue. Now, collecting my data from the question, I have it that the mass of copper deposited, mass of copper is equal to 10 grams, mass of oxygen is what you're looking for, you were not given, but the chemical equivalent of copper was given to us as 63.5, while the chemical equivalent of oxygen was given to us as 35, right? Let me say 31.5. Now, using the second law of electrolysis, because this is from Faraday's second law of electrolysis. Using the second law of electrolysis, you know that M1 over M2 is equal to chemical equivalent of 1 over chemical equivalent of 2. So, what is our first mass? Our first mass is 10 grams over X is equal to, what's the chemical equivalent of copper is 63.5 over what? 31.5. Now, making X a vector formula, you're going to have X to be equal to 10 multiplied by 31.5 all over what? 63.5. So if you do your calculations right, you should have 4.96 grams as the mass of oxygen. I believe that is clear enough. So before we round up today, we'll be looking at some applications of electrolysis. Number one is electroplating. When we're talking about electroplating, it's a form of electrolysis. It's a process that we use electrolysis to coat a metal. For example, your spoon that you use, some of your plates that you use are coated using electroplating. How does it work? If this is your voltmeter and this is the positive electrode and this is the negative electrode, the thing is, the metal that you want to use to coat another metal, you put it at the positive terminal. Let's say you want to coat a spoon using a silverish color. You put that silver here at the positive electron and you pass electricity through it. When you pass electricity through it, it will pass through this water through the electrolyte and leave through the negative terminal. But before it leaves through the negative terminal, if you're cutting a spoon, let's say this place, we have something like a spoon here. It will come here, deposit the silver color it picked from here, from the on this spoon, then it will leave through the negative terminal. This process is what we refer to as electroplating. We use them to coat many things: metals, body of a vehicle, spoon, etc. Secondly, we'll talk about extraction of metal. Extraction of metal. Most metals that we see, like our sodium, like our copper, they don't come in a pure form. They don't come in a pure form. They most of the times come in a mixture of one or two metal. So how do we extract such metal? How do we extract such metal? For example, now when we're talking about sodium, sodium is gotten from molten sodium chloride. Molten sodium chloride. Molten sodium chloride. Now, how do you extract it? You put the molten sodium chloride at the positive terminal. Put the negative, the molten sodium chloride at the positive terminal. So as the electricity is switched on, it will push the chloride to the positive terminal, to the negative terminal. That is how we use electrolysis to extract metal. Apart from that, we also use it to extract aluminium. We get aluminium from molten aluminium oxide. We use electrolysis to extract aluminium also. Thirdly, we talk about purification of metals. Just like I said, most metals don't come in a pure form. They don't come in a pure form. We can also use this to purify such metal. How? When you put on the electricity, it picks the metal that you need and leave the impurities here and deposit them at the negative terminal before the electricity goes out. Another thing is that we use it to calibrate ammeter. We use it to calibrate ammeter. That is a practical on its own. But how do we use it to calibrate ammeter? We use it to achieve or to determine the current flowing through an ammeter. We use the the Faraday's first law to calculate the time it will take 1 ampere of current to pass through that ammeter. That gives us the actual calibration of that particular ammeter. So, all that being said, this is your assignment. So you're going to try this and you're going to leave your answer in the comment box. I'll leave you with my WhatsApp number. You can send it to my WhatsApp. Calculate the time in seconds required electroplating of metal of 200 cm square. The time required electroplating a metal of 200 cm square and its thickness 0.05 centimeter. 0.05 centimeter is the thickness. If a current of 5 ampere is passed, so you're going to calculate the time. You're giving the density of the substance to be what? 8.8 gram per centimeter, while the Z, which is your electrochemical equivalence, is what? 0.0033 grams per coulomb. Please, in case you're contacting me via WhatsApp, contact me through this number 08064 818759. Please, your feedback is necessary, is needed. So drop your answer, what you get when you finish solving everything, in the comment box, or send it directly to my WhatsApp. Do have a nice day.